Hi, welcome to this Corbettmaths video. In this video, we're going to look at the laws of logarithms. So in our previous videos, we've looked at an introduction to logarithms. We've looked at how to type logarithms into our calculator and also logarithms in a little bit more detail and finding missing bases and missing values for x. But in this video, we're going to look at our laws of logarithms. In this video, we're going to focus on the laws and how to use them. Our next video will be deducing these laws. So if you're interested to see where these laws come from, feel free to watch the next video. But in this video, I'm going to focus on what the laws are and how we would use them typically in some questions. So here we've got some laws of logarithms. Now the notation that you may encounter may vary depending on the qualification you're sitting. So if you're doing A-level maths or GCSE further maths, or perhaps you're at university, you may notice that the notation slightly changes in terms of the letters that they use. But the rules are actually the same in terms of what we're doing. So here we've got, if we had log to base a of x plus log to base a of y, that's equal to log to base a of xy. In other words, if you're adding two logs with the same base, you just multiply the x and the y together, and it'll be log to base a of the product of x and y. If you've got log to base a of x, subtract log to base a of y, that's equal to log to base a of x over y. So in other words, if you are subtracting logs with the same base, you would just divide this value by this value and it'd be log to base a of that answer. And then finally, if you have log to base a of x to the power of n, you can actually bring the n down to get n times log to base a of x. So if you have log to base a of x to a certain power, you can bring that power down in front of the log. And we'll look at these in terms of where they come from in our next video if you're interested in that. Also, just to show you that you may use this notation for your laws of logarithms, but another way of writing it would be like this. Then if you've got log a plus log b, that's log ab. If you've got log a subtract log b, that's log a over b. And if you have log a to the power of n, you can bring the n down to be n log a. So those are the laws of logarithms. They're very important to know, and let's have a look at now some questions where we use them. So our first question says, write as a single logarithm. So we've got log to base 5 of 9 plus log to base 5 of 3. So we're adding together two logs with the same base, so we just need to multiply the 9 and the 3 together. So we'd have log to base 5, and then we would do 9 times 3, and 9 times 3 is equal to 27, because log a plus log b is equal to log ab. So log to base 5 of 9 plus log to base 5 of 3 would be equal to log to base 5 of, and then 9 times 3 is 27. So you can just multiply those values together. So that's our first question. Okay, let's have a look at our next question. So this time it says, write as a single logarithm, log to base 7 of 20, subtract log to base 7 of 4. So if we go back to our laws of logs, log to base a of x, subtract log to base a of y is equal to log to base a of x over y, or log a minus log b is equal to log a over b. In other words, you just divide. So here, if we have log to base 7 of 20, subtract log to base 7 of 4, that's going to be equal to log to base 7 of, and then we'll just do 20 divided by 4, that's equal to 5. So log to base 7 of 20, subtract log to base 7 of 4 is equal to log to base 7 of 5. So that's it, that's our answer. Okay, let's have a look at our next question. So this time we've got, write as a single logarithm, log to base 3 of 5 plus log to base 3 of 4 subtract log to base 3 of 2. So here we're going to be adding our first two together. Remember, if we're adding two logs, we can just multiply the values together. So remember, log a plus log b is equal to log ab, or if using this notation, log to base a of x plus log to base a of y is equal to log to base a of xy. So here, if we do log to base 3 of 5 plus log to base 3 of 4, that's going to be log to base 3 of, and then 5 times 4 is 20, so 20. And we've still got our subtract log to base 3 of 2. We've just added these two logs together. Now we're going to take away logs, and remember, whenever we take away logs, we divide, so it's going to be equal to log to base 3 of, and then 20 divided by 2 would be 10. And that's it. So log to base 3 of 5 plus log to base 3 of 4 subtract log to base 3 of 2 would be equal to log to base 3 of 10. And that's it. Okay, let's have a look at our next question. So next question says, write as a single logarithm, 2 log 5 plus log 3. So this time the bases are just going to be base 10, because there's log 5 and log 3. That's log to base 10 of 5 and log to base 10 of 3. If they don't specify a base, it's going to be 10. And also we've got a 2 in front of our log 5. And if we go back to our laws of logs, and this law says if you've got log of a to the power of n, you can bring down that power and have it equal to n log a. And likewise, if we've got an n or a number in front of our log a, a, we can bring it up as a power. So if you've got a power, you can bring it down, but also if you've got a number that you're multiplying the log a by, you can actually bring it up as a power. So if we go here, we can see this 2 in front of our log 5, we can actually bring it up as a power. So instead of writing 2 log 5, we could write that's equal to log 5, and then bring the 2 up squared. So that 2 can go up as a power. And then we've still got our plus log 3. Now 5 squared is equal to 25, so it's going to be the log of 25, and then still plus log 3. And now we're adding 2 logs together, so we can just multiply. So log a plus log b is equal to log ab. So log 25 plus log 3 would be equal to log. And then 25 times 3, well, 25, 50, 75. So it's going to be log 75. So 2 log 5 plus log 3 would be equal to log 75. That's a single logarithm. So in this one, we just brought that 2 up. We brought it up and wrote it as a power. Okay, let's look at our next question. So this time we've been asked to write as a single logarithm 3 log to base 6 of 2 plus 2 log to base 6 of 3. So this time we've got a number in front of this log and a number in front of this log. We're going to bring them both up as powers. So we're going to bring this 3 up as a power. So we'd have log to base 6 of 2 cubed, bringing the 3 up and writing it as a power. So to the power of 3 plus. And then instead of having this 2 here, we're going to bring it up as a power. So it's going to be log to base 6. And then we had 3. And we're bringing the 2 up. So it's going to be 3 squared. So then, I'm just going to scroll down a little bit. We've got log to base 6 and then 2 cubed. Well, 2 times 2 times 2 is 8. So 2 cubed is 8. And then we've got log to base 6 and we had 3 squared and 3 squared is 9. So it's going to be 9. So we've got log to base 6 of 8 plus log to base 6 of 9. But remember, if you've got log a plus log b, that's log ab. You can just times the 8 and the 9 together. So it's going to be log to base 6 of, and then it's going to be 8 times 9 is 72. So 72. So the answer is log to base 6 of 72. And that's pretty cool. We've taken this quite complicated question and we've got our answer of log to base 6 of 72. Okay, let's look at our next question. Okay, so this time we've been asked to write as a single logarithm, log 5 subtract 3 log a half. So this time the base is 10 because it just says log, so it's log to base 10. So we can just write down log instead of log to base 10. And we've got log 5, well, that's just going to be log 5. And then we've got subtract, and then we had 3 log a half. Now what we're going to do is we're going to bring the 3 up as a power, so it's going to be log, and then we've got a half, so a half, I'm going to put it in a bracket, and then we're bringing the 3 up as a power, so that's going to be cubed. So we've got log 5 subtract log a half cubed. We're bringing that 3 up and doing a cube there. Okay, now let's work out what a half cubed is, because that'd be quite nice if we knew what this is. So we've got log 5 subtract, and then we've got log, and let's work out what a half cubed is. So we've got a half times a half times a half, and a half times a half is a quarter, times a half would be an eighth, so that's an eighth. So we had log of a half cubed, well, a half cubed is an eighth, so it's now an eighth. So we've now got log 5 subtract log an eighth. Now remember, if you have log a subtract log b, that's equal to log a over b. So to work this out, we just now need to do 5 divided by an eighth. So that'll be equal to, because we're going to divide 5 by an eighth. So we'll do 5 divided by an eighth. And remember, if we divide by a fraction, we can multiply by its reciprocal. So 5 multiplied by 8 over 1. And 5 multiplied by 8 over 1 would be 5 times 8 is 40. And then 1 times 1 is 1. So it's 40 over 1, or just 40. Or how many eighths go into 5? There'd be 40 of them. So we've done log a subtract log b, or log 5 subtract log an eighth. And that's it would be equal to. So it's log 40. That's pretty cool. Again, that we had log 5 subtract 3 log a half. And the answer is just log 40. We've written it as a single logarithm. Okay, so those are our laws of logarithms. And just to recap them, if you have log to base a of x plus log to base a of y, that's equal to log to base a of xy. You just times them together. If you're subtracting logs, you can just divide. And also, if you have a power, you can bring that power down. So they're the laws of logarithms. Now, sometimes, rather than dealing with numbers, we might be dealing with algebra. So here, we've got right in terms of log to base a of x, log to base a of y, and log to base a of z. So in these questions, what we're going to do is we're going to split up these logarithms into log to base a of x, log to base a of y, and log to base a of z. So we're going to split them up. Okay, so this time we've got log to base a of xy. So we want to split it up. So xy, remember, if we go back to our laws of logarithms, if you have log to base a of x plus log to base a of y, you times them together to get log to base a of xy. So we could split this up into log to base a of x plus log to base a of y. So we're just going to split this up into log to base a of x plus log to base a of y. because if we had this, we would then times them together to get that. So if we've got that, we can split it up into the logarithms, but just remember we would add them together. Okay, let's have a look at our next one. So again, we've been asked to write all of these in the form of log to base a of x, log to base a of y, and log to base a of z. So this time we've got log to base a of z to the power of 3, or z cubed. So we want just log to base a of z. So here, we don't want this cubed, so let's bring it down. So that would be 3 log to base a of z. And that would be in terms of log to base a of z. We've got log to base a of z, so we've brought down the power. And that's it. Okay, let's have a look at our next one. So again, we want to split this up, and we've got log to base a of xy squared. So what I'm going to do to begin with is I'm going to split it up into, well, thinking of the fact that if we add logs together, we multiply. So this would be equal to log to base a of x plus log to base a of y squared. Because remember, xy squared means x times y squared. So that would be log to base a of x plus log to base a of y squared. Now we've got our log to base a of x, that's fantastic, but here we've got log to base a of y squared. We want it as log to base a of y, so we need to bring this 2 down, because remember, if you've got a power, you can bring it down in front of the log. So it'll be log to base a of x plus, and then bringing that 2 down, 2 log to base a of y. And that's it. So answer would be log to base a of x plus 2 log to base a of y. Okay, let's look at our next one. Okay, so this time we've been asked again to split it up, and we've got log to base a of x over y. So remember that if we take away logs, we divide. So this would be log to base a of x subtract log to base a of y. Log to base a of x subtract log to base a of y. Because remember, if we subtract logs, we just divide the x by the y here. And now that would write it as a single logarithm. So if you had that single logarithm, you could split it up into the individual logarithms. Okay, so we've done that. Okay, let's look at our next one. Okay, so this time we've got log to base a of the square root of xy. Okay, so this time again we want to split it up here. Now we've got this square root. Remember, square root means to the power of a half. So this would be equal to log to base a of, and I'm just going to write xz, and then close brackets and do to the power of a half, because we've got the square root of all of this. Okay, now we don't want this to power of a half here, so let's bring that down. So that would be equal to a half, and then we've got log to base a of xz, just bringing that power of a half in front of the logarithm. And now we want to get it in terms of log to base a of x and log to base a of z. So we want to split this up. So we've got a half of this, so that'd be equal to a half of, and then if we split it up, I'm just going to put some brackets in here. We'd have log to base a of x plus log to base a of z, just splitting up that log to base a of xz into log to base a of x plus log to base a of z. Okay, and one last thing I would do here is I would expand the brackets to get a half, and then log to base a of x plus a half log to base a of z. And that's it. So if we had log to base a of the square root of xz, I would first of all write the square root as power of a half. I'd bring the power of a half down in front of the log, and then I would split up the log to base a of xz into log to base a of x plus log to base a of z, and then just expand the brackets. And that's it. Okay, let's have a look at our last one. So this time we've got log to base a of the square root of y cubed z over x. Okay, so again, what I'm going to do is I'm going to write to the power of a half. So this would be log to base a of, and then I'm going to put our brackets y cubed z over x all to the power of a half, just getting that square root and writing it to the power of a half. Okay, now let's bring that power of a half in front of the log. So let's bring it down. So we've got a half, and then we've got log to base a of, and then in brackets y cubed z over x, close brackets. Okay, now what I'm going to do is I'm going to split this up. So we've got our divide here. So we've got a half, and then actually I'm just going to put square brackets here, and I'm going to deal with that half later. So splitting this up, because we've got our divide, we can write it as 2 logs subtracting. So we've got log to base a of our numerator, y cubed z, and then subtract log to base a of then the denominator, x, and then close brackets. So we're getting there. We've got the log to base a of x. Now we just need to split this log up. Okay, so I'm just going to keep the half outside here, so a half, and then I'm going to put our brackets, and let's split this up. So we'd have a log to base a, and then we were multiplying these together, so we'd have log to base a of y cubed plus log to base a of z, just splitting that up because we've got y cubed times z, so we can split up those logarithms. Subtract log to base a of x, close brackets. Okay, we're nearly there. We've got the log to base a of z and the log to base a of x. We just need to sort out this log to base a of y cubed. Well, let's bring the power down. So it'll be a half, and then open up our brackets, bringing the 3 down. 3 log to base a of y plus log to base a of z, subtract log to base a of x. Close brackets. Okay, so now let's just expand our brackets. So let's multiply each of these by half. So 3 log to base a of y, if we times that by half, that'll be 3 over 2, 3 halves, or half of 3 is 1.5, or 3 over 2, log to base a of y plus, and then these ones are quite straightforward, a half log to base a of z, and then subtract a half log to base a of x, and that's it. And that's it. So in this video, we've looked at our laws of logarithms, that log to base a of x plus log to base a of y is equal to log to base a of xy. So if we're adding logs together, we can just times the numbers together. Okay, next, if we have log to base a of x, subtract log to base a of y. Again, if we were subtracting, we can divide, so that would be log to base a of x over y. And finally, if you've got a power such as log to base a of x to the power of n, you can bring that power down in front of the logarithm, and that gives you n log to base a of x. And also you may encounter them in this form, that log a plus log b is log ab, log a subtract log b is log a over b, and log of a to the power of n is equal to n log a, and that's it. So in this video, we've looked at our laws of logarithms, we've looked at how to work out some numerical ones, and also how to deal with them whenever we're dealing with algebra. If you want to see where these laws of logarithms come from, feel free to watch the next video, which will be me showing you how we get these laws of logarithms, and that's it.